Okay, can you hear my voice? Hello, test.
Yes,
Okay,
okay.
okay. Thank you, Isha. The diagram shows, okay, the first question for the first model test paper. For the You're asking for um, a V potential different in a sphere, in a metal sphere. It's a positive charge sphere. Okay, positive charge sphere with a center 0. Point shows that S, O, W, X are on the straight line. Okay. So electric potential difference is the greatest between point. Okay, remember that if we're talking about E for a sphere, if E or a sphere, inside a sphere is always 0. So if we're talking about electric field, it goes up at the surface, and this one also goes at the surface. When it reach at the inside of the charge sphere, it will be 0. E will be equals to 0. Okay, but when we're talking about a potential difference across a charge sphere, okay, the same charge sphere, it will not be a 0. Okay, it never be 0. V will be has a value where it goes like this, goes up and goes down like that. Okay, it may be have a bigger than E, it may be lesser than E, but it has a value inside the sphere. Okay, so there's a difference between V and E. Potential difference inside the charge sphere has a value, and E inside of charge sphere doesn't have any value. It will be 0. Okay, I think we already discussed this two difference between E electric field and potential difference. So now we're talking about electric potential difference. So potential difference, if we draw back into the diagram, you know that there will be a value of V which we didn't know. Okay, it didn't say, and it goes drop down like this, right? Drop down like this. Okay, so you're asking for the biggest potential difference between. So we have a the difference will be if you have between x and y will not be the the highest because you only point here, this point, I'm making another color, between this point and this point. So did you see the difference are not so big as others? Okay, and W and 0 actually has the same potential difference. See this point and this point actually has the same value. W and X actually is the answer. You see their potential difference between this point A and B. You see that the gradient is higher. So actually answer is C. S and Y, S and Y has the same. Actually has the same. Actually maybe S over here. If we flip on the S, mirror the S, maybe S over here, but it is lesser than potential difference is lesser than this W and X. So answer will be C. Okay, how many of you got C as the answer? Okay, how many of you got C as the answer for number one?
Yes,
Okay,
sir.
okay, good. Okay, so number two, a nucleus with radius R is represented by this is atomic number 198 or 80 x, taking E as symmetry a charge and E naught as a permittive of surface. What is the electric field surface of the isolated nucleus X? So X, we know that X will be A and Z, right? Is it A or Z? Where A is what? What will be the label for A? What's the meaning of A? Hmm?
Total number.
Total number or mass number, right? Mass number. And Z is number of number of proton, right? So it's number of proton. So how much is the charge here? How much is the charge? How much the charge or electric the how much is the electron in this question? So you have 918 minus 80. Any more? 198 minus Hello.
Yes, sir.
198 minus 80.
My
Okay. So how much you got? So it will be 198 divided by 80. So 198 minus 80. So any more numbers you have to be minus? Hello. You can put in your chat down there. You can type in your chat window. Usha?
sir,
Hmm.
the Z is electrons, sir, number of electron.
Oh, number electron. It's not number proton.
Uh,
Okay.
so is
You can use the 80.
answer is A, yeah,
Okay, good. So we use the number of 80.
80.
Okay. So we have 80 number of electron divided by, you know that is Q over 4 pi epsilon naught and R, right? Okay, R squared. So we have 80 E, and then you have 4 pi epsilon naught R squared. So answer will be, how much is this? 4 pi, yeah, we have A as the answer. Okay, we are, why we did not taking E square, because it was a single, it's a single nucleus. Okay, it's a single nucleus, it doesn't have an E squared. If you have double Q squared, right, you'll be having Q squared, but this is a single uh, charge, and it's a sphere charge. Okay, now we go to the next question, number 3. A capacitor is first charged to 5 volt and then discharged through a 900 resistor. What is the initial current through the resistor? Okay, so initial current and discharge to a through a 900 resistor. So I don't think we're going to use a decay graph. Okay, where is the formula that has the exponent power. We use a basic one. Okay, the basic one is we have I naught equals to V naught over R. Okay, we have R naught not. We doesn't have any R naught. It doesn't exist. Okay, I naught equals to V naught over R. Okay, so this one 5 volts given divided by R is 900 ohm. Okay, there you have 5.56 times 10 power of negative 3 ampere, or we can have 5.56 milliampere. So answer is B. Okay. Uh, for capacitors, each of capacitance 2 microfarad are connected in such way as the equivalent capacitance is 2 microfarad. Okay, which the following arrangement is correct. So I you have to try all of them, A, B, C, D. Okay. Let's say this one for A you have, for A over here you have in series or in series. For B you have to make equivalent over here first. No, sorry, not this way. You have to make equivalent for above. Up. Okay, equivalent for A left and right, and equivalent for left and right, and then you combine these two. Okay, A and B as a parallel. Okay, so you have a series here combined into A, you have a series here combined into B, and then you have A and B as you combine them as a parallel. And this side you combine on top and the bottom as one equivalent resistor. These two are in connected in parallel. So after that you have to connect. You have to calculate these three in a series. Okay, and this one you have to combine these two as in the series as equivalent, and then you have 1, 2, 3 as in a parallel. Okay, so if you try everything, you can get the answer. Answer will be B. Okay, answer will be B for number 4. Question number 4. Okay, exactly you have 2 microfarad. Okay, anyone got that one correct for number 4? Anyone here got correct for number 4? Yes, Abi raised hand. Okay, next question is question number 5. Our current flows in the wire circular cross-section area a free electron drift velocity of v. In the same current flows in a similar wire 3 times the radius the drift velocity of electrons is. Okay, so we have a current that flows in the cross semicircle, cross circular cross. Okay, so this is a circular cross. Okay, A, and free electrons have a drift velocity of v is the same current flows in a similar wire 3 times the radius. Or you're asking what happen if they have a same wire, a same amount of current that flowing, but we have a bigger A, 3 times A. Okay, 3 times A. What will be the drift? How much is the drift right now? Okay, so it goes back to the only formula for drift velocity is I equals to Navi. Okay, Navi. And from Navi, we only the things that uh, change over above image. I mean the diagram on top and bottom is only the A. Okay, we have a current that is flowing. The same current is flowing. Okay, so the same current flowing. So we only can change this A. Right? We only I can change the A. Okay, so N V E and A is equal to pi. Actually, A is 2 pi r square. Sorry, it's a pi r square. Okay, so it means that NVE pi r square, and we know that V, okay, V as a equation title, so I divided by N E pi r squared. So this one will be V. So actually you know that V is direct proportional of 1 over r squared. Okay, V equals to direct proportional of 1 over r squared. So if we R is triple. Why R is triple? R times 3. So R, if 1 over 3 R squared, okay, what will happen to V? So we have 3 squared is not 1 over 9 R squared. So V will be smaller by 9. Okay, V will be smaller by 9. Okay, let's say this one is V naught R naught. This is V1 R naught. Okay, so we have here, we can change into 1 over 9 R naught squared, R naught squared, still number 9, and this is V1. So V1 is is V1 is over 9. No, 9 is smaller. Over 9 over 1 over R naught squared. Is it? Okay. V1 is lesser than 1 over R squared. Okay. So essentially you have to know that V1 will be smaller than yeah, there you have here V over 9. So answer is D. So diagram shows a wire of length 6 centimeter consisting of iron core diameter of 3 millimeter surrounded by copper external diameter of 4.0 mm. Okay, the resistance of the wire R, resistance, this is resistance R. Wire is resistivity. Okay, resistivity, the symbol of resistivity is uh, uh, what call this one? Rho. Okay, and the copper is 1.7. Okay, so we erase the 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 text, the drawing first. So remember, when we have this kind of arrangement, we have inner, we have outer and inner, okay, layer. Both of them actually are connected in parallel. Okay, both of them are connected in parallel actually. Okay. Uh, so how to solve this kind of question? We have to do, you have to combine them, or you have to calculate them into a parallel formula. Okay, first of all, we do the iron first. Okay, so the resistance of the iron is equals to rho, that is the resistivity of the iron, times the length of the iron. Of course, they have the same length actually. We don't need to put the L also. Divided by a area of the iron. And you know that area of the iron has a different case of area of iron is not same as area of copper, right? Because copper is actually a segment of, you see, this is iron inside, and copper is not a uh, perfect, uh, perfect circle. Okay, it's only outer layer, the area of the copper. Okay, so it goes back to the formula. R copper equals to rho copper times L of the copper divided by A of the copper. This one will be tricky, A for the copper, because copper you have to minus back the area have taken by the iron. Okay, so this is the R. Then you have to put, we have to continue with 1 over R copper plus 1 over R iron will be equals to uh, 1 over R total. So it goes to uh, uh, A. Okay, A actually why is A on top is because 1 over is 1 over rho copper, for this case copper, and L copper divided by A copper. So A goes up on the numerator. So A divided by rho L. This is iron, and iron. This is iron, and plus with A copper divided by rho copper and L copper. Okay, rho copper and copper. Okay, so we want to substitute all the numbers. So for iron, it will be pi 1 over 5 times 10 power of negative 3 squared. Okay, because pi r squared. And 1 times 0 times 10 power negative 7 and 0.60. Okay, plus pi, and this is the key part because we have to minus. Okay, going down, pi and 2 times 10, 2.0 times 10 power negative 3 squared minus 1.5 times 10 power of negative 3 also squared, because we want to get the outer layer of the copper only, it's not the inside. Okay, so 1.7 times 10 power negative 8, this number came from here, the copper. Okay, and times with 0.60 as the length of the copper. Okay, so if you have calculate, put in your calculation, so 6.81 as the answer. Okay, and you have the R will be equals to 1.52 times 10 power negative uh, what is it, negative 3 ohm. Okay, why this is 1 over R, so you have to flip back, you have 1.52 times 10 power negative 3 ohm. Okay, so answer will be A. Okay, so I got question for number 5. Okay, Abi, what's the question for number 5?
Sir, I got B.
9 times.
Yeah.
How come you got 9 times? It's 9 times smaller.
V is inversely proportional to radius, right, sir?
Inversely proportional to
Radius.
radius. Okay.
Sir, I take photo and send in group.
Okay. What we have is in question number 5 is V is directly proportional to 1 over R squared. Okay. And this is V naught, V naught and V naught. Okay. So next thing we have V after, means that after the increasement of the what I call the increment of area, I put as a after. Okay, is directly proportional to 1 over 3 R naught squared. Okay, so 3 also has to be in squared. So you have VA is directly proportional to 1 over 9 R 0 not 2 squared. Okay, so okay, so you have to compare V naught and VA. Okay, so how does, I think if you divide, can you divide? Can you divide both of them? I mean, this is as first equation, this is second equation. 1 divided by 2. I think you have V, you get V A over 9 equals to V naught. Is it? You check back your calculation,
Sir,
Abi.
I moved the 9 to the V.
9 to the V. How about you divide 1 divided by 2 or 2 divided by 9? You end up with VA over 9 equals to V naught.
Sir, I show you the photos in group.
Okay. I don't have my handphone right now. Okay. Uh, where's my handphone? Later after the class I will show you. Can? Abi?
Okay, sir, okay.
Okay. So next one. Okay. Is question number 7. Total power delivered uh, electrical power, sorry. Okay. Electrical power source internal resistance R is used to compare a lamp of resistance R. What fraction of the total power is delivered to the lamp? Okay, so it's asking for a fraction. What fraction? So you know that the fraction uh, fraction is output over input. Okay, so first of all we have to find how much the output. Okay, the output uh, oh yeah, the output will be equals to 1 over 1 squared r. This is power of output. Power of input is equals to I squared and r plus r, because it says that the source has internal resistance, so input has internal resistance r plus r squared. So you have I squared r divided by I squared and r plus r. Okay, so you have cancel the I squared, you have r plus r, so answer will be B. Okay, question number 8. The diagram shows a constant DC voltage of 12 volt connected to resistance. Okay, what will be the voltmeter reading? So it says that in the voltmeter we have a resistance inside the voltmeter. Okay, so we draw back. This is 12 volts, and we have 3 ohm, 3 kilo ohm. We have 6 kilo ohm, and goes back to the supply. And again, in the same, we have 1 kilo ohm of resistor. Okay, of course, we have done this one before. We have to rearrange the resistor into equivalent resistor down there. Okay, so we have 1 kilo ohm plus 3 kilo ohm in the parallel is equivalent to the green resistor is equivalent to 3 over 4 kilo ohm. Okay, it's equivalent to 3 over 4 kilo ohm. Then we have to use what you have to use? We have to use the uh, potential divider formula. Remember, V equals to R plus R1 plus R times back V. This is we have to use so many times again. So are we using on this side this V? Okay, so this V is actually R. The R is 3 over 4. 3 over 4 divided by uh, 3 over 4 plus 6. Okay, plus 6 will be over there. And the total of power is 12. The total of EMF is 12. So you have actually the V is equals to uh, the V will be equals to 1.3 volts. So answer will be C. Okay, answer will be C. Any question about this question number 8? Any question number 8? I think we have done like 3 times already. Question that's involving a potential divider formula. Kihang, are you okay with this? Kihang? Kihang, are you there? Is it in the group or not? Or it's not? There. It's in the group. Okay. Now, question number 9. Represent variation of magnetic flux density at center of plane circular coil. We have a radius of the coil, so we have a coil and radius with a certain radius r. It can be further r because it says that it doesn't say that on the coil, it can be outer of the coil. So this one will be the center of the r. So we know that F equals to BIL, and B actually U naught I over 2 pi d or 2 pi r. Okay, and it times with IL. So from the equation we know that F is directly proportional to 1 over R. Okay, 1 over R. Okay, so answer is A. Answer is sorry, B is 1 over R, so answer is D. Okay, goes down, directly proportional, inversely proportional. Oh no no no, this is B. Okay, goes back. So B is inversely proportional 1 over R. Okay, so there you have a B. B equals to U naught I over B equals to U naught I over 2 pi R. So B is directly proportional to 1 over R. Then your answer will be D. Okay, current does the same magnitude flows in the form affected by distance D. Magnetic force. Okay, so this is F B I L and B is U naught I over 2 pi D. Okay, so using the distance of D, and this is IL. So F is inversely also inversely proportional to D. So you have question number 10 will be answer will be A. Okay. Okay, so I think we stop here. Abi question I will answer in the group. Okay. Maybe we check back with the equation. Right. It should be smaller.
Okay, sir.
Any question until question 1? This is question number 10. Do you have any question? Let's go back to the question. Any question?
No, sir.
No. Okay. So we stop here. Uh, there is no
Thank you,
class
sir.
on Saturday and Sunday. Okay. Have your holiday. Okay. Bye.
Okay, sir.